Hello everyone, welcome to another video on integration. I'm still looking at indefinite integrals and u-substitution as a technique of evaluating integrals. Now in this video I have 5 questions that are a little higher order questions with regards to u-substitution. So the first one is we're supposed to evaluate this integral of x plus 4 over 2x plus 3 dx. Now if I differentiate the denominator, you find the answer is going to be 2 because derivative of 3 is 0. But in the numerator, I have x plus 4, which means I need to do something. I can't apply u-substitution directly. So let's look at what we need to do here. Our first question, let me just capture the question first. Number one, it's the integral of x plus 4 all over 2x plus 3 dx. Now I want to produce the denominator in the numerator. In other words, I need to have 2x plus 3 in the numerator. So how do I do that? First is to obtain a 2x. So I have to multiply the whole numerator by 2. But I don't want to change the integral, so I have to divide by 2. So this will be equal to 1 over 2. That's dividing by 2. The integral of 2x plus 4 all over 2x plus 3 dx. You notice that these 2's can cancel. You still have the same original integral, but we don't cancel it because we want to produce 2x plus 3 in numerator. So this is going to be half of the integral of 2x plus 8, if you expand that, over 2x plus 3 dx. I'm going to rewrite the numerator there to 1 over 2, the integral of 2x plus 3. Remember, I have to say plus 5 because I have 8 there, all over 2x plus 3 dx. Now I'm going to use term-wise division now. So this is going to be half the integral of 2x plus 3 all over 2x plus 3 plus 5 all over 2x plus 3. And then I have dx. Now, obviously, you can see that this is 1. So this is half the integral of, if I bring this bracket out there now, I'm going to say the integral of 1 and distribute dx there, dx plus the integral of 5 over 2x plus 3 dx, like so. Now let's move on to the next page. On our next page, we're going to have, if I can have it here, we're going to have, yeah, you can see it from there. We're going to have, this is going to be equal to 1 over 2, open brackets. The integral of 1 is actually x. And then I'm going to say plus 5 is a constant. But if I differentiate the denominator, I'm going to get 2. So I need a 2 in the numerator. But first, let me take 5 out. So 5, the integral of 1 all over 2x plus 3 dx. Now, if I differentiate the denominator, I'm going to get 2. So I need a 2 in the numerator. And therefore, if I'm going to multiply by 2, I have to divide by 2. So this changes to, let me remove this one now. Right, just a minute. I'm gonna need original question at the end. All right, like so. Right, so this changes to half. I have x, and then I'm gonna have plus 5 all over 2, the integral of 2 all over 2x plus 3 dx. Take note of that. These 2's can cancel and still have my 5 there. But now I'm gonna let 2x plus 3 be equal to u. So that part, I have to work on that because I've evaluated my first term, the integral of 1, this one here. I evaluated the integral of 1, and I got x, and I have to work on this part now. So I'm going to let u be equal to 2x plus 3, and therefore du dx, I'm gonna just take dx on the other side straight away. Du, if you like, this is gonna be 2 dx. Remember, du dx equals 2, and then multiply by dx both sides. That's what you're gonna get. And if you look at 2 dx up there, so I can have 2 dx, I can have du there. So now what I have is I have 1 over 2 outside, and then I have x plus 5 over 2, and then I have the integral of du over u. Notice 2 dx is du, and then down here 2x plus 3 is actually u. And we know the integral of u is 1 over u. This one is 1 over u. Integral of 1 over u du. Let me rewrite it so that you can see it clearly. We have 1 over 2, and then we have x plus 5 over 2. This is what I'm saying, the integral of 1 over u du. So this is exactly that. And integral of 1 over u is actually natural log of u. So this is going to be equal to 1 over 2. And then I have x plus 5 over 2 times natural log of u. Like this. And then I have to say plus c, because I'm done now with evaluating both integrals now. The integral I had at the beginning here and the second one. Now, u has to go because my original variable is x. And the connection between u and x, from here you can see that u equals 2x plus 3. So this will change to 1 over 2 x plus 5 over 2, the natural log of 2x plus 3, and then plus c. Multiply by 2 by half throughout. This will simplify to 1 over 2 x plus half times 5 over 2 is going to be 5 over 4, natural log of 2x plus 3, and then plus c. So that's the final solution to our integral. Like I said, these are higher order questions involving u-substitution. There are a lot of things that you need to do for u-substitution to come out clearly as a technique of integration that should be applied. Let's move on. So we're done with this integral here. This was our first integral. Now we're moving on to our second integral. Our second integral, again, a little bit more involving, is this one here. This is our second integral. Here it is. There you go. Very tricky, obviously. We're supposed to evaluate the integral of 5x square root of 3 plus x dx. Now, obviously, when you have a radical like this, you'll have to get rid of it first before before you can even continue with the integration. So we're going to let this expression under the squared sign as equal to u, and then carry on from there. So let's get number 2. Let me capture the whole question here. So we have right here, you can see there. So number 2, we have the integral of 5x square root of 3 plus x dx. What I said is you let u be equal to 3 plus x. And obviously, if you differentiate with respect to u, you can just have du equals dx, if you see what I mean. Because du dx equals 1, because that is a constant. Derivative of a constant is 0. So du dx equals 1, and therefore du will be equal to dx. But in here, I have x outside there. So I have to solve this for x. So this implies that x, if you agree with me, it will be u minus 3. That's my value of x. So I perform triple substitution actually. That has to go, that expression has to go, and that has to go. So this integral then changes to the integral of 5. Remember, x is now u minus 3. And then square root of, remember 3 plus x is u, and dx is du. And this can be rewritten as this, the integral of, here it's going to be 5u minus 15. Outside here, I have u to the power half. Remember, that's square root of u du. Distribute u power half through across. You're going to have the integral of 5 u power 1 times u power half is going to be 3 over 2. And then we have minus 15 u power half. And then we have our du outside. Now let's perform the integration. I'm going to have to distribute everything throughout my integral sign. So that's going to be the integral of 5, if you like, u power 3 over 2 du minus 15, the integral of u power half du. Integrating this part here, remember the power is 3 over 2. I'm going to add to 1 and I get 5 over 2. So I'm going to have 5 over 2 as a power and I'm going to divide by 5 over 2, the denominator. So that's 5 u, the power 5 over 2, and I'm going to say divide by 5 over 2. And then minus 15, integral of this, half plus 1 is going to be 3 over 2, and I'm going to have u power 3 over 2, and then I'm going to have all over 3 over 2, and then I'm going to say plus c. Now let's simplify this. So this part here, 5 divided by 5 over 2 is actually 2. If you check the arithmetic there. So this is going to be 2 u to the power 5 over 2 minus 15 divided by 3 over 2. If you do your maths there, it's actually going to be 10. 15 divided by 3 over 2 is going to be 10. So that's 10 u to the power 3 over 2 plus c. But what is our u? Our u is, if you can see here, u is exactly equal to 3 plus x. So the u must go. My final solution then is going to be 2, 3 plus x to the power 5 over 2 minus 10, 3 plus x to the power 3 over 2 plus c. That is my final solution to this integral. These are higher order cases of u-substitution. They are even higher order cases than these questions. But you know, you start from concrete to abstract. So we started with very easy questions in the other video that I've produced. In this one here, higher order questions, and we'll come back with even more complex cases for calculus 2. Right, so this integral has been evaluated. That's integral number 2. Let's move on to integral number 3. Right, our third integral is this one. You can see they are not looking very friendly. So we are supposed to evaluate the integral of 3x plus 6 over x squared plus 4x minus 2 dx. Naturally, when you see the quadratic expression in the denominator, what comes up in your mind is the trig substitution. But we have to first of all check, is it possible for us to use other techniques of integration? Obviously, u-substitution comes in. If you differentiate the denominator, you're going to have 2x plus 4. But in the numerator, I have 3x plus 6. I need 2x plus 4 there because of this x. So I need to have 2x plus 4, which means I need to do something before u-substitution can be applied. Oh, so here is how it's going to go. Number 3, integral number 3 is the integral of 3x plus 6 all over x squared plus 4x minus 2 dx. Like I said, I need, when I differentiate this, I get 2x plus 4, so I need 2x plus 4 there. So I have to multiply by 2 first, and therefore I must divide by 2 also. So half means dividing by 2, or the integral, multiply that numerator by 2. So 3x plus 6 all over x squared plus 4x minus 2 dx. Now just expand that. You're going to have half the integral of 6x plus 12 all over x squared minus plus 4x minus 2 dx. Now factorize the numerator in such a way that you have 2x plus 4 there, and obviously you're going to take 3 as your common factor. So this is 1 over 2, the integral of 3, open brackets, 2x plus 4, there it is, all over x squared plus 4x minus 2 dx. So I'm going to take the 3 out. So this is going to be 3 over 2, the integral of 2x plus 4 all over x squared plus 4x minus 2 dx. There you have it. Now I can let the denominator be equal to u. There is your u substitution coming out now. So we're going to now say let u be equal to x squared plus 4x minus 2, and therefore du is going to be equal to, differentiate this, is 2x plus 4, and then I can have dx outside like so. Now, if you notice, this expression here is basically 2x plus 4 dx, because dx is up, is not in the denominator. So the whole of that can be replaced by du. Let me rewrite it so that you can clearly see what I mean. 3 over 2, the integral of, check this out, 1 over x squared plus 4x minus 2, and I'm saying times, check this out, 2x plus 4 dx. Now you can clearly see that this expression here is that expression, which is du. So I'm going to have 1 over u du outside 3 over 2 like this. This should be sufficient space. All right, so I'm going to say this is equal to 3 over 2, the integral of 1 over u, and then what must I have here? Du. And what is the integral of 1 over u? It's a natural log. 3 over 2 times the natural log of u, and then plus c. Now, we are saying this u here has to go because u is equal to x squared plus 4x minus 2. Now, sometimes you have to drop off these absolute value signs. Now, in this case, we have to check whether is it possible that this can be negative or positive. For you to do that, for you to be sure, you have to complete the square of that, which I want to demonstrate here as quickly as I can, to just check, because sometimes you will have to drop these absolute value signs here. So what am I checking? I'm checking x squared plus 4x minus 2. This expression, is it possible that it can be negative? So what do? We take 4, which is the coefficient of x, divided by 2 square, add and subtract, so that you don't change anything. So this is x squared plus 4x plus 4 minus 4, and then minus 2. Remember, that's your special 0 right there, because this minus that is just that one there. But you're going to have to factorize this part, which gives you x plus 2, open brackets, close, squared like this. But minus 4 minus 2 is minus 6. So yes, this can be negative, depending on what the value of x is. For example, when x is 0, this can be negative. And therefore, we have to use absolute value signs. So we must maintain that. So our final solution then is 3 over 2, the natural log of the absolute value of x squared plus 4x minus 2, and then plus c. That's our final solution right there. Right, so that's the end of question number 3. Let's move on to question number 4. I told you these are a little bit higher order cases, a bit involving, but with practice you should be able to handle these ones. Let's go to number 4, and here is number 4. Integral number 4. We're supposed to evaluate the integral of x squared over x plus 1 dx. Now, again, if I differentiate this, I'm going to get 1, because derivative of 1 is 0, derivative of x is 1. But I have x squared in the numerator. So it means I must do something in the numerator. So what am I going to do? By looking at x plus 1 here, it tells me that I have x squared there. I have to take advantage of what we call difference of 2 squares. So let me capture the integral first. This is number 4, and the integral is x squared all over x plus 1 dx. So I'm going to have to perform a trick there. Special 0 coming up again. The integral of x squared minus 1 plus 1 all over x plus 1. And then I'm going to say here dx. Take note, minus 1 plus 1 is 0. So it means I'm still having that expression at the beginning there. But I'm going to have to use term-wise division. So this is equal to the integral of x squared minus 1 all over x plus 1. And then there's a plus sign there, plus 1 all over x plus 1. And then I have the x outside there. Difference of two squares here. This is the integral of x plus 1. And then I have x minus 1 all over x plus 1. And then I have to say that I must have a square bracket here, plus 1 over x plus 1. And then dx. Clearly you can see that these cancel. So what do I have? I have the integral of x minus 1 plus 1 over x plus 1, and then I have dx. Distributing the integral sign and the dx there, I'm going to have the integral of x dx minus the integral of 1 dx plus the integral of 1 over x plus 1 dx. Now, what is the integral of x? Well, the integral of x is x squared over 2. Remember, you add 1 and then divide the answer you get. So the power is 1 here. 1 plus 1 is 2, power 2 over 2. Minus the integral of x of 1 is x. And then I must show you that the integral of 1 over x plus 1 is actually natural log of x plus 1. And then plus c. I'm going to show you just now. This would be our final solution. But let's explain why the integral of 1 over x plus 1 dx is the natural log of x plus 1. I'm going to do it here. I want to show you that is equal to actually this one. The integral of 1 over x plus 1 dx, you use u-substitution. Use u-substitution. You say let u be equal to x plus 1, and therefore du will be equal to dx. And then I come here and I say this is going to be the integral of 1 over u and then du. And what is the integral of 1 over u? Remember, it's a natural log of u. But what is u? X plus 1. So this will be natural log of x plus 1, like so. That explains why that must give you that. And then you have to add a constant there because we're dealing with indefinite integrals. Right, this is the end of integral number 4. We have one more, number 5, and then we're done for this video. Let's move to integral number 5. Integral number 5, and our last one for this one is there it is. The integral of x open brackets 1 minus x to the power 99 dx. Now clearly we have to use u-substitution here because you can't expand that. So here is how it works. Number 5, we have the integral of x open brackets 1 minus x to the power 99 dx. So I'm going to say let u be equal to 1 minus x, and obviously you can see that du equals minus dx. But here I have dx, so multiply by minus 1 both sides or divide by minus 1 both sides. You're going to have minus du equals dx. Now, I have x outside here, so I must solve for x there. This implies, if you agree with me, that x is actually going to be 1 minus u. That would be x, 1 minus u. Take x left and u to the right hand side, you're going to get 1 minus u. Let's perform triple substitution, that, and that. So this integral then will change to the integral of, instead of x, I'm going to have 1 minus u. And then here I'm going to have u to the power 99. And then I have du, minus du actually, minus du because there is dx is minus du. I'll take minus outside. So this is minus the integral of, and I'll distribute the u power 99 across there. So I'm going to have u to the power 99 minus u to the power 100. But remember, it has to be in brackets like so. Du actually, not dx. My hand is used to dx here. Just make sure that you are awake all the time when you're performing evaluation of these integrals. All right, now we can now distribute this across. So it's going to be minus the integral of u to the power 99 du and then a minus, we change that sign to plus, plus the integral of u to the power 100 du. And what is this? Well, this is minus, I'm adding 1 and I'm dividing. So it's minus u to the power 100 over 100 plus, add 1, divide, u to the power 101 over 101, and then plus a constant. Now, let me come back here and fix this. This is du. So now, remember u is actually 1 minus x. So, and I'm going to write the positive term first. So my final answer is going to be 1 over 101, open brackets, 1 minus x to the power 101. And then I have minus 1 over 100. And then I have 1 minus x to the power 100. And then plus my constant c. So that's the final solution to this integral. All right, this is where I'm going to stop in this video. If you're new to the channel, please don't forget to give us feedback, comments. We value your comments. Invite friends to subscribe and share these videos. It will help us build the channel and give us the ability to generate more videos. All right, I'll see you in the next one.